Hello everyone, we are live again. Let me just fix some things. I have no idea why Prism does this, but every time I start streaming, my settings go berserk and I have to configure things again. But it's okay. Let me just fix the settings and arrange my windows. And I hope you can see my screen. We are live on Twitch. Oh, adjusting the screen size is really weird. Okay, cool. This should work. And we are also live on YouTube, at least we should be. And we are also live on X, so you can watch me there as well. I have to actually figure out if how can people find my X live stream? Because yeah, so if you go on X, you can just see a notification if you follow me that leveling up is live. I am live there, and you can see my stream there. So yeah, if you want, you can also follow me on X and watch the stream there. I have to figure out how can I see the comments and stuff here, because it is a little bit more confusing. People following my X live. Okay, at least we are live at all three platforms. And similar to before, so let me just give a quick introduction again. I am Aditya Bansal and I am solving LeetCode questions to level up in Python. I am following the simple top interview 150 question list, not because I'm preparing for any interview, just because this is a good list to follow. Because they have a sorted list of this is the type of question you're solving, and they have a good variety of easy, medium, and hard questions. The hard questions we are leaving for last. First, we are approaching all of the easy and medium questions. And once we are done with that, we will move on to the hard questions. Maybe at least I will try them. I did some hard questions. These were easy hard and not that difficult. But yeah, hopefully we will be able to tackle more hard problems in this list. My goal is to complete this list in the next 30-40 days, something like that. So let's see how we make progress on that. I did three medium questions on LeetCode yesterday. We did rotate image, set matrix to 0, and game of life. Ransom note I have done previously, but I think I might have done it at some random points. So let's just do it again. I think for today we will be able to solve these four easy questions, and then maybe we can move on to the first medium question in the hash map list. And let's see how this goes, because maybe we will get a surprise and one of these easy questions is not actually easy, they are medium. So by keeping that in mind, let's move forward and approach the first easy question. Given the two strings ransom note and magazine, return true if ransom note can be constructed by using the letters from magazine and false otherwise. Okay, I think I remember doing this recently. So okay, but still, let's just do it on live stream, because since you're streaming and I want to go in sequence. So given these two strings, these are easy questions, so we should be able to iterate through them pretty quickly, but we might get stuck somewhere. So Yeah. Ransom node is A and then magazine is B. And since A cannot be return true if, so we cannot create ransom node by the characters of magazine. So okay, so basically this is like that movie question that people who send ransom nodes actually do it by using the magazine cutouts. I solved this problem before, but that never crossed my mind. But good thing. These guys are funny as well. So we have all of the characters. We can do character count uh, of all the characters in magazine. And then we can iterate through the ransom node. And if like here we do +1 basically on character count, and here we do -1. If at any point it goes below 0, if at any point we run out of characters, then return false. Characters, then return false. Another nice approach that I follow is to write comments, and these comments explain my reasoning behind like what I'm trying to do and how I'm thinking about the solution, because that usually helps in explaining my approach to others. Like live streaming is a good example of where I have to speak out what I'm thinking, like how am I going to solve this problem. But it also helps in when you're in an interview situation or when you have to uh, keep talking to move forward in a problem and approach much harder problems. It comes in much more handy at that point. But yeah, it's a good approach to follow. Hmm. So if we'll go first +1, then -1 at any point if it's we run out of characters, we return false at the end. If we reach the end, then return true. Okay, so let's just code this. We can do a array of 26 characters. That's one way if we have like only a lowercase English letters. So that makes things easier because we can do character count. How this works is basically you go A minus A in like ASCII is 0, and then Z minus A in ASCII is 25 something, or I think it should be 25. Yeah. So we have like indices of where we want to uh, go in this array, and then we can just update that position. We don't have to maintain a dictionary or anything. This ensures like we have one time that we learned yesterday that use a bitmap or something like that. So if we go for character in, first we'll go magazine because that's what we have to check. Magazine character count of, we get ordinal value of our character minus we get the ordinal value of our small a. So this will be +1. So we are currently counting up how many characters we have in the magazine string. And similarly for character in a ransom node, we will go character count. So here we have to perform a check maybe before that. If character count, let's also get like position will be this, and then character count at this position is positive basically. So if it is 1 or above, then we say, okay, we have a character to add for this. So we just do -1. Our work here is done. And else, if if we are unable to find that, if it's 0, we are never letting it go into the negatives, because here is the only place where we are performing the negative -1 operation. So if we come across a case where this is false, meaning this is 0, then we just return false because our condition is not satisfied. Otherwise, if we reach the end that all of the characters are satisfied and none of them return false, our answer should be true. Sorry, true. Okay, it works on the basic test cases. We are using a bit more time, but I know that these are not very reliable. So let's try other things. We know that this takes some amount of, we can also do character counts using dictionaries. We can do character count using a dictionary. And this way, we'll do a character count of directly the character is equals to character count get if we have for that character, then other else we get 0 and then +1. And similarly for this, we will not need the position. If our character count is if our character is in this character count dictionary, then we do character count of that position -1. And if that character count reaches 0, is 0, then we just delete that. Otherwise, if we are not able to find it, we return false. Let's try this approach. Yeah, it's still equal in time, and we've not made like much of a difference here. Again, we're iterating 2 times. We're not doing anything else. Other thing we can do is so we have to iterate over both of them essentially because we don't know which one is going to be lower. Maybe we can save time by saying like if magazine is less than ransom note, then just return, because if that's the case, then we will say like, okay, it is not possible for any magazine characters to create the ransom note because they don't have enough characters. So maybe we can try that simple check. If length of magazine is less than length of ransom note, then we'll just return false. Yep, no difference. Another thing we can do here is just use the default dect. So from collections, import default dect. And then here we can say default dect and integer. I guess this does set it to 0. Let's see. And now if we go plus this, but then this doesn't work because it creates a empty thing. So now we have to check if character count. So then this is like a little bit messed up. So I don't think using default dict is the best option here. So let's not do that. And we'll go to solutions now to see if someone is trying out some new things. Simply we count characters of magazine and count each character of this. They are doing the same thing. They're creating a hash map. And if the current character is not in mega hash, if count of the current character is now 0, we should return false, like the same thing we did. So they are updating the hash and then returning true if they reach the end. Otherwise, we just add -1 and yeah, O of n plus m will be our. This is not useful, so let's just remove that. And instead of default dict, let's just stick to dict. And yeah, so we are iterating over this whole thing once, which is O of, let's call it m. It doesn't matter what we call what, but O of m and then O of n. And then for each of those, we are checking the characters, which is like O of 1 operation. And then we are doing this 20, like our space maximum should be taken is 26, this. So that's constant O of 1. Sorry, I have a like noise in background. It's just India. It happens. So we check the hash, and if it is it, this is the first thing we wrote, that get, otherwise 0. Otherwise we put +1. And if it is not in this, or it is 0 or equal to -1, return false. Okay, so this is something where we can simplify our code. Let's just comment this part. And if our character is not in our character count dictionary, or character count dictionary of this position is less than equal to 0, then we say that, then we just simply return false. Else, we don't need an else. Let's just put it. Actually, we can use else. I think I would like to try both approaches. What happens if we do character count -1 only always without checking? Okay, so this will only be executed if we didn't already return false from here. So it is already like a conditional thing. Otherwise, if whenever this if is satisfied, we just return false. We never get here. So I guess it's the same. Uh, Character count. We have some issue. Yep, it's supposed to be character. So it's running for the test cases. Let's try to submit it for the final submission. Yeah, it stays the same, not much of a difference. Another cool feature of LeetCode is that you can just go into the solutions and see which solution runs the fastest. And if you see something like a one-line simple like this approach, and don't worry too much about it. Maybe you can see what other people are doing. They're using a counter. So we can try using a counter because that's another one of the famous approaches that we can see a lot of people have submitted at this timestamp, and this is the solution, one of the solutions that work at this timestamp, this fast. So we can just count all of the characters in both of those. And then for note, we just go into those. And if the magazine is less than however much we need, then we return false, otherwise true. So this is another cool approach that we can try. We have our original approach. So we can mark it as approach 1 using count, like basically hash map and manual counting, but manual in the sense like we iterate and then we count. And we can try another approach like approach 2, which will be using inbuilt counter class. counter, is it counter class or counter function? I guess it's called counter function, right? We can have, yeah, let's just call it like built-in counter. So first we'll import it. I think it's from collections, import counter, which will help us count all of things. And then we can just pass the whole thing. So note map, I can call it, and that will be counter. And then in the counter, we pass the ransom note as a whole string. And then in the second one, we have the magazine. So we can call it just magazine map. And that will be another counter. And that will return, we'll pass the magazine and this one. So these will return us dictionaries. So we'll have the uh, dictionaries of characters and their counts. Right. So now we have both the dictionaries. Now we can iterate the character and the number of instances we have seen of it. So character and then value. We can just call it value or something else. So in, so we have to like check for note map because we don't care how many of these are in magazine. We have to just satisfy that however much are in the, just 1 second. Yeah, we just have to satisfy that however many are there in the note map, at least that many are already present in magazine map. So if in magazine map, the characters are less than however many we need, then we just return false. Otherwise, we return true. Because we have satisfied that all of the characters that are in note, magazine map already also has at least that many characters in it. So we don't have to worry about, like, we can recreate the whole note using just the characters from magazine. Let's try to run it. Okay. Not enough values to unpack. Okay, it should be items. And it's working on the test cases. Let's try to submit it. Yep, we got around that range. So yeah, counter is another approach that we can take based on like if we are using inbuilt classes like counter from the collections library, we can utilize counter to create dictionaries very easily. I guess these things like manual approaches work better in interviews whenever you are trying to explain your reasoning. But whenever you are doing this in like production and trying to build a system, there's no point in writing all of this manually. You just use the counter class and then simplify your process, simplify your code. It becomes easier to maintain, obviously. So we completed the ransom node. Let's move to isomorphic strings. Next. It's another one of easy questions. 205 isomorphic strings. We have two strings S and T. Determine if they're isomorphic. I don't know what isomorphic means, but two strings S and T are isomorphic if the characters in S can be replaced to get T. So all the occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character, but a character may map to itself. So let's see. So basically they have to be equal in size. I think that will be yeah, that's a given. They are equal in size. And paper, title, foo and bar cannot be made because as O needs to be mapped to both A and R. Okay, so basically we need unique ones, like G can only be mapped to D. So we will iterate from the first character. We will map the E to the character here, and then that cannot be mapped to any other character. So just a quick way of how I would go about this is create a dictionary, create a map, hash map. Since we are solving hash map questions, we'll just call them hash maps. So we'll create a hash map to keep a track of all the characters that we have already mapped. Characters that we have already mapped. So when we first see E, that will be mapped to A. And then another time when we see E in our S string, then we need to make sure that the next time it's also A. If it is something other than A, then we return false. Otherwise, if it's A, it's okay. So we have the case of G. It first maps to D, and then the second instance of G also maps to D. So this becomes true. And the last case that we are given, that in the second case we are given, O first maps to A, and then we have the mapping. O is mapped to A, and then again O comes and that says that I want to be mapped to R. Then we return false, that no, O, you cannot do that. So we have the character map, and it's a dictionary. We are solving hash map questions. And for uh, character, and so we one thing I want to check is, can we do iterations on both of them together, like something like for character 1 comma character 2 in, like we zip both S and T and then we iterate on both of them together. Otherwise we can use simpler approach like for I in a range, and then we do that. So let's ask Grok that. Hey, I am working on solving a Python problem, and I was wondering if I can iterate over two strings simultaneously or using some code like this or not. So let's see. Yeah, Grok now has like this cool markdown format. Yes, you can iterate over two strings simultaneously using zip functions, and your syntax is correct. So yeah, I guess the correct syntax. Wow. So this is our syntax. Let's try iterating. So we have character 1 and character 2. Otherwise, we can also like follow the boring approach of using a pointer and with like indexing. But we have character 1 and character 2. Now we check if character map already has a mapping. So if it has a mapping, or we can do, okay, let's not overthink. If character 1 in character map, then we check if it is already there, yeah, and uh, the value, the character map value of character 1 is not equal to character 2, then we return false. This is the only case when we are returning false. Else, if it's same, then we just have to, either if it's same or it is not present, then we can just say character map of character 1 is equals to character 2. If it is already there, we can also nest this, but I think it's going to be the same. So let's just do this instead. And if we reach the end, then we can just say that it's true. And let's try running that once. So this works on the test cases. Let's try submitting it once. Okay, we have a wrong answer. Let's use it as a test case. So we have B, A, D, C, and then, okay, so no character should be mapped to any character as well. So we need to make sure that it's free. It's the same on both sides. So either we can like also have a reverse character map that tracks it. So Yeah, basically we need some way, like either we can use a array or we can use a dictionary. It's the same uh, in these smaller cases. So let's create a reverse character map. It's also going to be a dictionary, and then we are still iterating over both of those. So if uh, character 1 is in character map and it's not matching this one, elif character 2 is in character map and reverse character map, and the value of character 2 is not matching. I think we can simplify it a little bit, right? If first we check either of these are in the respective maps or not, if character 1 in character map, then basically we can guarantee that the other is also true, no. Or basically we have to check both of this. So if character 1 or character 2 is already in the map, oh, it will complicate things. So let's keep them separate like we had before. So we check the first thing like we did. If character 1 is in its character map, then we check if it's matching the thing we are trying to match it to or not. Else, we again check that if character 2 is in character reverse map, then if it doesn't match the character 1, then also it is equally incorrect and we have to return false. And in an ideal case, when both of these are either matching or they are not present, then we just update both of the maps, character 2 with character 1. So we are also updating this so that if either one of these conditions fail, we return false, otherwise we continue. Currently, if all of the characters are like A, and then in the other string is also the same, these are the operations we are doing again and again. We can save time on these to just make sure that they are only happening 26 times, but that will need additional like nesting. So let's first see this approach. We'll also try that one. That's what we are doing, trying random things. Okay, so this approach work, we are just checking for both of these cases. Now let's try the very minute quote unquote optimization. So we'll just comment this out. Then we'll go again, character 1, character 2. And then this time we'll go first, we'll use a nested thing. So if it is in character map 1, I can share my GitHub profile. Thank you very much. And let's just copy paste it. Your profile. I can comment it in Twitch. Oh, I cannot paste it here. Okay. I think you can see it. I am unable to paste it for some reason in chat, but I can just type it. 7 is my user ID, and then you just have to put github.com in front of it. Awesome. Yeah. So if we go about nesting, then we just do the two checks in 2 steps. It doesn't save that much of anything, but we are just doing it for fun. We return false, and else if it is true, then we do nothing, right? So if character 1 is in character map, we check this thing and we do nothing. Elif, we check character 2 in character map, reverse character map actually. And then we say if this is not true, if this, then we return false again. And then we can do else, like character 1 is also not in character map, character 2 is also not in character map. Then we put both of these things in the correct maps. so that we are saving 1 millisecond of time. Yeah, it's like exactly I felt like 3 milliseconds is saved. Yay. So we saved some operations here, but let's see what other people have done to solve this problem. This person let's actually post like so many solutions, and all of their solutions are really well explained. So I just try to see if they have posted a solution. They also created like two hash maps. Simply, each character of both strings should be a pair. That means their indices should be the same. So A should be okay. So if it is something else, compare the indices of E and A. They are same, which is no problem. Move next. G and D are these, and move next. G and D should be index 1 because we already found the character at index. To prove that, we have these. Compare G and D, they are at index 1, which is no problem. Okay, so instead of doing like a two-thing check, they are just checking the indices of if both of the indices are same. So they don't have to write two different like this nested. They can just check if both the indices are not same, then something has messed up. And E, G, and then A comes again. A is a new character. A is at 0. No, A is at 2. D is at 1. Yeah, this is also fine, right? Let's see a false case. You will understand the algorithm if the last characters are A and D. So we have E and G, and then D is mapping to two things. Okay. So they also have like O of N. We are iterating over all of the strings, both of the strings just once, and both of them have the same size of N. And for each of those, they followed the simpler approach of just using I. And if it is not, then just put it there. If it's not there, just put it there. If they are not the same, then return false. So this simplifies things a little bit because we are just first checking if it's not there, just place it, which is basically this. If it's not there, place it. If it's not there, place it. And at the end, we check if both of the indices are not same, then return false. Is this any better than our solution? That's the main question to ask. So mark this as approach 2. And then we'll go again, just move away from this. We have two dictionaries, character map and reverse character map. Let's also comment this. We'll just call them smap and then tmap. And then we'll iterate. I will still iterate like this because I'm having fun with this one. So we'll iterate through both of the characters. If character 1 is not in smap, then we put it there. Smap. Okay, we need indices for this approach. Okay. We can also enumerate this, but let's not overcomplicate things. For I in range a length of S, if Si is the character not in smap, then we say smap, please take Si, index Si, and similarly we do for T. for t we have this, and then we check if it is correct or not. So we'll go E we have, so we don't update that. A we don't, so we don't have this, update this, we don't have this, update this, we don't have this, update this, we don't have this, update this. And then we'll go, we don't have this, update this, but we already have this, so don't update this. So this will be a new thing that's added, and then that will be like, oh, it's not the same, and return false. So if if map of si is not equal to t map of ti, then just return false. Otherwise, if we reach the end, we return true. I think I have that written already, so no worries. This is working on the test cases. Let's try submitting it. It's the same, no major difference. Like another approach, we can see this, that if they are not the same, they are already the same, that's given condition. So let's not worry about that. We create a single dictionary, and if organization is not, if this is just a little bit more complex code for no reason. But yeah, I guess we have tried like 3 approaches now, and all of them work, so we can move on from this question. I can just do okay. Yeah, so one of the major things that I don't think people understand is the fun part about LeetCode is that you can try a lot of different random iterations. You can see a lot of different solutions by different people and how they are approaching things. Because when you actually go into creating production systems, things become a little bit more streamlined, and you have to just follow the most efficient approach. You cannot just goof around and experiment. So that's a liberty that we have while experimenting with LeetCode, and it's a good thing to have. Now that we have solved 2 questions, let's move to the third one for today. It's another easy one, so we'll iterate through this one pretty quickly as well, hopefully. The next question is word pattern. Given a pattern and a string s, find if s follows the same pattern. Here, follow means a full match, such that there is a bijection between a letter and a pattern, and a non-empty word s. Specifically, each letter in pattern maps exactly to one unique word in s, and each unique word in S maps exactly to one letter pattern. No two letters map to the same word, and no two words map to the same letter. So it's essentially the same question that we did before. Here, instead of like words, characters, we have complete words. So a simple thing we can do is split it. So we will split the pattern string into a list of strings, and then we will follow the same approach as before. We will create 2 maps, the simple character to pattern map, character to pattern map, and pattern to character map. In this case, if we think back to our previous last approach, maybe that won't work here because we have complete words instead of just that can still work because our indices will still be here. We will still have dog at index 1. So let's try to implement that approach here. So we will have the uh, pattern list. Let's just do s dot split. I don't actually remember the syntax of splitting. How to split a string based on spaces. Grok. Just grok it. So yeah, my approach was correct. S.split will give us a list. This will give us a list of strings that we can iterate on, and we already have the pattern. Okay, so this should be a word list, right? So if we go for I in range, another thing I like to do just for fun is just create a separate variable for counting. I don't need to worry about like writing this whole thing again in the n, and then we will iterate again if we'll have to create two dictionaries, two hash maps, two hash maps, and then in each of those one will be character to word, or we can just say character map, and that will be a dictionary, and then we will have a word map that will also be a dictionary, and both will each one of these will store the index of first appearance, right? So if we see that something from the pattern I is not in a character map, then we insert that in the character map. Character map is equals to I. And similarly, if we see that something from the word list is not in the word map, we insert word map and then word list. We insert the position of the first instance of that. And if at the end, the word map, this whole thing doesn't match this whole thing, then we say that, okay, return false, because the same approach as before. A was mapped to dog, so this was 0. Dog was also 0. Then again we see A, this was already set to 0. We don't change that. Dog is already mapped to 0, so we don't change that also. But if something like this happens, A is mapped to 0 and dog is mapped to 0, then again when A comes, we don't change A, it stays at 0, but fish comes and fish is now at like index 3. And then we check that, okay, 0 and 3 don't match, return false. Otherwise, if we have iterated over all of the things, then we will just return true. Hopefully they are the same length and we don't have to check that. Okay. They don't have anything else. So one thing we can check here is if n is not equal to the length of word list, then we can return false that, okay, they don't match. So we can return false here. Let's try running that. So we got false for this one. We are returning true for the fish case. Why is that happening? Let's see. So we can simply print, maybe print that for let's use the f string for pattern I. We can say the character map of this is this whole thing, right? And then similarly for word map I, we have the word map I thing, and then the word map I thing in the word list. So now we can see the what are the positions that are being updated. For I use Python because I am a AI ML developer. I've been studying that for past 2 to 3 years. I solved most of these questions previously in C++, but that I found like no one actually cares about that. People in interviews nowadays don't care if you're using Python or any other language. So I switched to Python. I previously worked at like Turing, and there the whole thing was Python. So I've stuck to Python since then. So if I was doing like core competitive programming, I obviously use C++ for that. I did like LeetCode competitions and code chef and stuff. For that, I use CPP. But now I've just like, for fun, I have shifted to Python. And this is just like me trying to get better at Python, because I think LeetCode is the best way to understand data structures and algorithms. Because even if you create large projects, you don't use a lot of these rudimentary data structures and algorithms. You don't experiment. You don't see what other people are using as their solutions. So that's why like just lead code for practicing Python and getting better at it. Otherwise, no other big reason as such. So for A, we are going with 0. Dog is also 0. But for fish, like here we are updating. This is not supposed to happen. Okay. So yeah, this is supposed to be pattern I, not N character map. And just a second. Okay, awesome. Congratulations, you're in your final year. Just to give you some context, I have already graduated. I have completed my master's, so this is more of a fun side hobby for me. And all the best for your final year. So if we see for awesome. Yeah. So now we have updated. Let's try running it once. Oh, we have wrong answer again. Why? Awesome. Thank you very much for following me. Yay. Hope to see you again on the streams as well. And also excited to see what progress you make in the future. And so if A is not in character map, we are adding that to the this. A is 0, dog is 0, B, and then B is again. Okay, so why is this updating? Why did I forget to update it? Not in. Yep, it should be correct now. Let's comment this out and try submitting it once. Yep, it works. Now time for some fun experimentation. We'll try random things and see what works, what doesn't, what don't. And so this is like, okay, let's try removing this once. Do we have any thing given? No. So let's try submitting this without the first condition and see if that makes any difference. Okay. So yeah, this is not the case. We can have like more. Here we only have 3 things. Here we have 4. So yeah, this is a must. We should maintain this. And then for character map and word map, currently we are doing index iterations. We can also try, so let's just mark this as approach 1. And then maybe we can also try uh, using the character map, character to word map and word to character map. Like it will be, we will be performing more operations essentially. So I don't think that's a good thing to do. Let's try to look at the solutions, what other people have done. Again, I'm trying to look for if Nets has proposed a solution or not. Short in Python. Let's try to do it in one line, I guess. Yep. So S is pattern and T is the split. Then just map S dot find and then T dot index. Okay. And if they are exactly the same, and then we just put it that way. So let's try to understand this code, like how to do it in a cryptic way. So let's copy it. I'm using Grok as my partner to understand the code. Help me understand this code uh, where we are essentially performing this operation, uh, essentially forming these operations, but in a more Pythonic way. Python, uh, the main thing I'm trying to understand is the last line with this. So that's like the main reason why I do LeetCode is because I find approaches like these, which use like a simple map and then s.find, t.index, which I don't usually use in practice. But this is like I am getting exposed to new syntaxes, new ways to solve the same problem. Uh, Instead of using like the long for loops and stuff, there's always a more Pythonic way to do things. So let's try that. Uh, Give me a explanation. Yeah, the first two things are like simple. We have SS pattern, TS this, and then we split to create a list of strings. And then this is the main part we are trying to understand. This line is at the heart of the solution. It checks if the pattern of the first occurrences of the character in S, that is pattern, matches the pattern of the first occurrences of words in T. Let's break it down. So basically, I am guessing that s.find does the same thing as t.index. Maybe they both find the first location of both the things. S.find is the string method find, which returns the index of the first occurrence of a string in the string S. Yep. Applies map. What map does is that it applies s.find to each character in S. For each character C in S, it returns the index C where it first appeared is. Okay. So this will give us the whole basic map. And then again for T, we are doing the same thing again. We will create a map based on t.index in the method. It returns the first occurrence of the element in the list. So basically these are doing the same thing of finding the first occurrence. They have done another lambda function that's it's a default dect, and then they are doing s pattern, and then the whole thing again. It's a dictionary with s. Uh, this is also like again cryptic version. From here, they have made it more cryptic, but I don't think we need to go into that much detail as it's okay. Like this was the thing that was making me curious. So let's try this. We'll keep this part. We will keep the word list. We'll keep the check. Comment out this whole part and also return true. And then we will try just close the solution. We don't need the solution now. We'll try to uh, remember it. So we have s dot split. Sorry, we already did s dot split. So we have s dot find, which finds the first location, the first instance of each character. So the character, and we will map it for each of the characters in S. And then again, we have another one, which is t dot index. Is it named T? My narrations, that's just practice. Like I speak a lot for some reason. So yeah, this is like another big reason for like me doing live streams. It helps me to build up my pace. I am talking to essentially just you right now. I guess you're my only viewer right now. So this helps me practice for interviews, future potential interviews, that I can just blabber whenever I go there, and I don't pause a lot in that situation. So here I can mess up a lot of times and no one is judging me essentially. So it's a good way to practice things, and then you put it in practice in the when it matters. So we'll do word list because we are not naming it S. Uh, awesome. Yeah. So what was pattern? Uh, Pattern is this string. So it should be pattern.find in pattern, and then word list is we are doing indexing, and this will, let's just try to print it once, see what happens. And this should be character map, and this should be word map like we named things before. And let's try printing them once. Print, just let's print character map goes to character map, and then our word map also goes to word map, and we are returning just true for now, just for fun. We don't care about the solution right now. We are just printing things to see what is the result. Oh, nope. We have to iterate through them. Is there a way to print them in line? Is there a way I can print the map in a single string or something like this? Let's take this. Let's take this. Or do I have to write a loop to print things one by one? Let's see. Uh, okay, it's a iterator, so we cannot print it directly like that. Let's see if there is some way we can join it. Still complex. Why do we need to do this? So we can do join with a empty space. We are converting this into a string, and then we are taking the whole map. I don't want to do that. I can just say for what do we have in this? Like it's a map, or is it a dictionary? It's a list. It's a map. A dictionary. What is it? Um, it should be a dictionary, right? Yeah, it should be a dictionary. So let's say key, comma value, and character map dot items print key value, and then the same thing again for this. It just goes to word map, and we remove this part, and it should technically work. Nope, it doesn't work. What is this map? Like, what is the data type of this? So let's try print type of character map. What does it return? Is it a unique data structure or something? It's a map. A map returns a map. How to iterate a map in Python using a loop? For index. Okay, so it does not give us like a. But I want both things, right? I want the index. That's like a funny thing. So the map only returns like the index of like, okay, what is the for? Oh, okay. So for each one of these, we get like indices, and like this will be the for index 0. Then this should also be 0, and then that should match. So if we only get like these numbers, we don't get the whole key value pairs. Now index, and we say index again. Repeat same thing. Run it. Yep. Why do I forget to make changes? Okay, so we are getting 0, 1, 1, 0. So both of these are extracting their things. Now we just check or return if character map is equals to word map. If they are the same, true. If they are not, false. Nope, incorrect answer. Why is it an incorrect answer? Let's see. I have to go back. What was the thing that was printed? Okay. And it's giving me 3. Why is it giving me 3? Wordless.index. We split it in the same way that they did. Uh, okay. We split it the same way. And then we mapped it the same way. And then what is this? Why are they doing str.split? Is there some pattern? And then we have s. S is pattern. For some reason, they have flipped this. But map.find, in our pattern, we are finding things. And then in our list, we are doing this. Is this the thing that's causing an issue? This is causing issues because in s.find we are getting 0, 1, 1, 0, and here we are getting 0, 1, 1, 3. So we have to troubleshoot this on why wordless.index is not working. We have a wordless, we have split it in the same way. We have map and then we have the whole thing. And let's just do one thing just for the fun of it. Let's do T. For some reason, this is named T, and again T, and then again T, and then again T. What difference does it make? It doesn't make any difference. Right, so this is not correctly working. This is causing issues. Let's see this to Grok. This line is causing issues and not working correctly. It is giving me Is the thing incorrectly split? So let's try printing the word list. Word list is word list. Let's try printing that. So we have dog, cat, and fish. So it will be 0113. Yeah, so 0113. It is supposed to be false. What are we returning? Yeah, this is working correctly. Is this not causing issues? This is working correctly. Now, if the character map and is equals to word map, then we return true, right? Else we return false, right? Or can we iterate over the map only once and at the end map is empty? I don't see that. Let's try to comment this out. Run it. It's dog, cat, dog. What's happening? Right, and then we have the word map, the word list is this whole thing, and then these should map to the correct things. If I run this, 0110 and 0110, they are both the same, and we are returning false for some reason. Ah. Will it change anything if I just write return this part is equals to this part here instead of like at the end? No, right? It shouldn't change anything. So this double equal to operation is not working correctly then. Because we checked that both of these are 0110, 0110, and we are still returning false for some reason. Let's just try to do it even more brute force way. For index 1, index 2, and zip them both. Character map and word map. And if index 1 is not equals to index 2 at any position, then we return false. At the end, we just return true. Right. So here we will also print these. This for fun. Index 1, comma, index 2, and try to run it. So this one worked. When we explicitly check, it worked. And when we were doing just a simple, the whole check, it was not working. Let's try submitting this one. Oh, again, wrong answer. Okay, because I changed it back. Okay, awesome. This solution also works. Great. So the major two takeaways from today is like one of the best things about LeetCode that most people don't understand is that LeetCode is a good way to practice any language, even if you're familiar with it, because it gives you a chance to iterate a lot of solutions with a lot of like various approaches, see what other people are using to solve their problems and how to approach the same problem using multiple data structures and algorithms, make things fast by 1 millisecond and stuff. And the other thing that we like learned was that lead code is actually just fun to solve. Like lead code questions, they just run you through different exercises, which you don't get when you are working in like a production system because you have to follow like rigid rules and you are just working mostly with classes and functions and creating high level stuff. You're not getting into the nitty gritty, and lead code gives you a chance to do that. So today we solved one, two, and three questions. The plan was to do four, but we were not able to get there. So this was it for today. Thank you for joining in. We don't have the regular viewer Solaris today, but we're missing him. Hopefully he joins us soon. And thank you for joining Dragon and uh, both of you. So thank you very much. And for anyone who is watching the rerun, thank you very much for giving your time as well. See you guys in the next time.